It seems like everybody wants to become an AI engineer right now. And I get it. The salaries are insane, the demand is through the roof, and honestly, it's one of the most exciting roles in tech right now. But here's the problem. Most people have no idea where to actually start. They go on Reddit, they ask ChatGPT, they get these overwhelming roadmaps with like 47 different things to learn, and they end up just spinning their wheels for months without making any real progress. So in this video, I'm gonna give you the exact topics that you need to learn in order, step by step, to become an AI engineer as fast as possible. No fluff, no filler, just the stuff that actually matters. Let's dive in. Step 1, you need to be comfortable with Python. Now, I'm not saying you need to be some kind of Python wizard. You don't need to know every design pattern or be writing compilers, but you do need the solid fundamentals. Now, I'm talking about functions, classes, working with dictionaries, lists, making HTTP requests, handling JSON, this kind of stuff that you work with every single day. If you can write a basic Flask API or a command line tool that actually does something useful, you're in pretty good shape. And that's really the bar, right? You have to go above that, but that's at least the minimum that you need to know. Now, the reason Python is a non-negotiable is because literally every AI tool, every framework, every API, every client library, they all use Python first. LangChain is Python. The OpenAI SDK is Python. Hugging Face is Python. Of course, they have other languages, but generally speaking, all of the AI stuff just goes to Python first. So if you're not comfortable here, everything else that I'm gonna go through is gonna feel a lot harder than it needs to be, so nail the Python fundamentals. Now, step 2, you need to understand how large language models actually work. And I don't mean the deep math. You don't need to go and read, the attention is all you need paper and understand every equation. That's a lot more on the research side of things. But what you do need is the mental model. You need to understand what tokens are and why they matter. You need to know what a context window is and why you can't just dump your entire code base into a prompt. You also need to understand things like temperature and other parameters, why sometimes you get a random answer, sometimes you get something predictable, and you need to understand the role system as well. System messages, user messages, assistant messages, because this is how every single API call is structured, and it really makes the foundation of practical AI engineering. If you understand these concepts, you'll be able to debug problems, optimize your prompts, and actually reason about what's happening instead of just copying and pasting random code or having an LLM, funny enough, generate a bunch of code for you. Now, before I go too deep with the rest of the steps, I do want to talk about something that's very important, and that's how you should actually be learning these concepts. Because the method matters just as much as the actual topics. In fact, it probably matters more. Now, here's the thing. Studies have shown that when you're just watching tutorials or reading blog posts, you're only absorbing about 20% of the material. But when you learn actively by actually writing code and building things, that retention jumps to as high as 75 to 90%. Now, that is a massive difference. Now, that's why I personally always recommend DataCamp. Their platform is super interactive, and you're writing real code and getting instant feedback from day one. Now, DataCamp is sponsoring this video, and I want to tell you about their Associate AI Engineer for Developers track because it's genuinely the fastest way to build the skills that I'm going to go through in the rest of this video, and it's very hands-on and something I used myself. Now, the track is 26 hours of interactive learning where you'll build real AI applications, chatbots, recommendation engines, and semantic search systems using the OpenAI API, Hugging Face, LangChain, and Pinecone for vector databases. It also covers LLM ops, so you'll learn how to actually deploy and maintain AI systems in production. You'll handle rate limits, API exceptions, and structuring model outputs for reliability. Now, that's the stuff that employers actually care about. And once you finish that track, you can take the AI Engineer for Developers Associate certification, which includes a timed exam and a 4-hour practical exam where you build a real AI app. Now, that's a credential that you can put directly on your LinkedIn and that's recognized in the industry. Now, right now, DataCamp is offering 25% off using my link in the description. So if you're serious about becoming an AI engineer, then check it out. All right, so now we move on to step 3, and this is where it gets fun. Now, this is where you want to learn how to build with LLM APIs. Now, specifically the OpenAI API and the Anthropic API. Now, these are obviously the big ones right now. Of course, there's a lot of other ones that you could use, but there is a difference between someone who uses ChatGPT and someone who builds with AI by actually calling the LLMs directly. Now, you need to know how to make API calls, how to handle the responses, how to structure multi-turn conversations, and how to deal with errors gracefully. Because these APIs will fail on you. They have failed on me way too many times, especially when I'm trying to record a video, and ideally you need to understand how to work with them in production. So start simple, build a basic chatbot that can answer some questions about a specific topic, and then build something that takes user input, sends it to an LLM, does something useful in the background, generates a response. The goal here is to get really comfortable with this request response cycle and understanding how to actually control these LLMs and call them from code. It's not always a user directly just messaging an API. This could be an LLM filling in some new entry in a database for you. It could be doing something in the background. It could maybe not even be user facing. This is where you start to actually see what's possible with AI engineering. So now we move to step 4, which is prompt engineering and structured outputs. Now, I know prompt engineering sounds like a buzzword, but this is legitimately one of the most important skills that you can have as an AI engineer, especially in 2026. Now, the thing is, getting an LLM to give you a decent response inside of ChatGPT is relatively easy, right? But getting it to give you a reliable, consistent, structured response in a production code base, that is a completely different game. If you've ever tried this, you know exactly what I mean. Now, you need to learn how to write system prompts that actually constrain the model's behavior. You need to understand function calling, where the model doesn't just return text, it returns structured data that your code can actually use. And you need to learn JSON mode and structured outputs so you're getting predictable, parsable responses every single time. The key here is to get the models to do something reliably and consistently. Now we move on to step 5, and this is RAG and vector databases. Now, RAG stands for Retrieval Augmented Generation, and this is hands down the most in-demand pattern in AI engineering right now. Most AI applications are using some kind of RAG, and if you know what I talked about before and RAG, you can build some really cool apps. Now, here's the overall concept. So LLMs are trained on general data, but your users want answers about their specific data, their documents, their code bases, their company knowledge base, whatever, right? Now, RAG is how you break that gap down. You take your data, you convert it into embeddings, which are basically just numerical representations of certain pieces of text, and you store those in a vector database, something like Pinecone, Chroma, there's a lot of other options out there. And then when a user asks a question, you search for the most relevant chunks and you feed those to the LLM along with the question and any additional context. The LLM can now reason based on that data, and this allows you to get way better responses. So now we move to step 6, which is learning orchestration frameworks. Now, this is where you go from building simple, single call apps to building real complex AI systems. Now, the two big ones here are LangChain and Llama Index. Of course, there's a lot of other ones as well, but these are frameworks that let you chain together multiple LLM calls, build agents that can use tools, manage memory, access conversations, and handle complex multi-step workflows. Now, think about an AI agent that can actually search the web, query a database, run some calculations, and then summarize everything for the user. That's orchestration, right? So overall, what you want to focus on in this step is orchestrating LLMs, doing retries, having multi-stage processes, having different LLMs chat with each other, right? It doesn't matter what type of frameworks you're using. It just matters that you can orchestrate a more complex flow that isn't a single API call. So now we move to step 7, which is LLM ops and deployment. Now, this is one that many people skip, but to be honest, it's probably the most valuable one and what most employers are really looking for. And that's because building a cool AI demo on your laptop is one thing, but running it in production where real users depend on it, that's a completely different challenge. Now, you need to understand rate limiting because these APIs have limits and you can't just blow past them and send a million requests. You need to understand caching because every API call costs money and you don't want to pay literally thousands of dollars for the same responses. You also need monitoring so you know when your app is breaking and you can kind of see what's going on. You also need to think about cost management because again, LLM API builds can get out of control extremely fast. Now, this is what separates a side project from a real product, and this is one of the skills that most employers are looking for, LLM ops. So now we move to step 8, which is to build a portfolio. Now, I don't mean a portfolio of random tutorial projects that everybody else has. I mean real projects that solve real problems and show that you can ship something end to end. Now, here are a few projects that absolutely will stand out that you can take some inspiration from. Now, number 1, build a RAG chatbot that can answer questions about a specific domain. Could be legal documents, medical research, whatever, it doesn't matter. But build something, deploy it, and have people actually using it. I know RAG seems simple, but to get it to work in the real world reliably is a lot more difficult than it seems. Next, build an AI agent with tool use. So something that can browse the web, interact with APIs, maybe create files, change something, interact with the environment. That's extremely useful and something that could actually be used by real users. And then another interesting project could be to build a semantic search tool. So you could take a big data set, something like product listings, articles, job postings, whatever, and build a search system that uses LLMs that doesn't just understand keywords and like random strings in the text, but actually understands the meaning. If you can put these on a GitHub, you can deploy them, you have clean readmes, you can explain them in an interview, you're already ahead of 90% of applicants. And this is something that, again, absolutely can make you stand out. Of course, make them your own, make them more advanced, make them actually useful. But the point is, you need these types of projects in your portfolio. Okay, and then finally, we move on to step 9, which is to multiply your output with AI tools. And what I mean by this is understanding how to actually use AI tools to create AI systems. How do you use Cursor? How do you use Claude Code? How do you use Warp? How do you use all these different agent orchestration platforms? How do you make it so that you can produce more code than everybody else and do it in a way where you actually create something meaningful? Now, as an AI engineer, you absolutely need to know how to use these AI tools in your development environment. And funny enough, by using these AI tools, you actually start thinking about how they work, and it makes you better when you design your own AI tools. It's kind of this paradox, like AI engineers are using AI tools to build more AI tools, then get built to use more AI tools. Anyways, you get the idea, but you need to do this. And then lastly, moving on to step 10, you need to pass the interview. This is a completely different video on its own, but generally speaking, you need to be well prepared. You need to probably go through some of that leak code grind, do some machine learning interview prep. And if you want a great interview prep platform, I actually work with a company called AlgoExpert. They have a machine learning expert interview prep section specifically for ML, AI, and all of the topics I talked about in this video. So consider checking it out from the link in the description. Anyways, guys, those are my steps. Let me know what you think of the video in the comments down below, and I look forward to seeing you in the next one.